So here we have two problems involving secants. One we're solving for the segment lengths, and the other we're solving for the angle measure created between the two secants that are extending from the same point outside the circle. So here, let's look at the first one here on the left. So we have this equation here. We have CB, the length of CB times CA. So let's look at that. The length of C to B, that's from the point outside the circle to the point of intersection, times the length of the entire secant from C to A there. That is equal to the same thing on the other side, from the point outside the circle to the initial intersection times the length of the whole segment. So let's go ahead and see how that's defined. It says that CB has a length of 2. It says that BA, so from B to A, let's label that from here to here, on the inside is equal to 2x plus 5. So that tells us this on this initial side. CB is equal to 2. And then CA is made up of C to B, which is 2, plus B to A, which is 2x plus 5. And then the same thing on the other side. We have C to D here, which is 3. And then we have from D to E here is x plus 3. And I'll write it this way, x plus 3. So again, the initial segment is equal to that initial segment times the length of the whole is going to be 3 plus x plus 3. And now it's just a matter of simplifying. So we'll simplify inside the parentheses first, combine like terms, leaving us with 2 times 2x plus 7 is equal to 3 times x plus 6. Then we'll distribute, giving us 4x plus 14 on the left and 3x plus 18 on the right. Then we'll go ahead and subtract 3x from both sides. When we subtract 3x here, they cancel. When we subtract 3x here, and then that'll leave us with just x. And when we subtract 14 from both sides, we're left with 4. So x is equal to 4. So on this other problem, we're solving for the angle C, which is this angle in between here. And it is similar to when we're working with just tangents, or we're working with tangents and secants. We have the angle is equal to this far arc, A to E, and subtract from that this close arc of BD. So we'll just throw in what we know here into our formula. It says that angle C is 4x plus 7, and that is equal to the measure of arc AE is 15x minus 21. And we have to be careful to put these in parentheses because we're dealing with this subtraction in between. And when we have an expression, that subtraction is going to, that minus sign is going to distribute. So BD, the arc BD, is 3x minus 1. And that is all going to be over 2. So the first thing we want to do is distribute this minus sign in, making it a negative 3x, and then negative and a negative is a positive. So we can write 4x plus 7 is equal to 15x minus 21 minus 3x plus 1 all over 2. Then we will multiply both sides by 2. To get rid of that, we'll need to multiply both sides. And then we can combine like terms over here at the same time. We can take 15x, subtract from it 3x to give us 12x. And then taking negative 21 and adding back 1 will give us minus 20. And over here we can distribute this in, giving us 8x plus 14. And we're almost there. So now we can just subtract 8x from both sides, canceling here, minus 8x. That gives me 4x here. And then add 20 to both sides, add 20, giving me 34. And then finally we would just divide both sides by 4, giving me a final answer of 34 over 4, or 17 halves is my final answer.